Hello. Let me start screen sharing. Okay, you should see the desktop. Is everything okay? Can you hear me? Do you see the desktop?
We can see.
Yeah, I'm trying to get the chat up there. Great, thanks. It's not. Okay, yeah. Okay, now I got the chat up. Okay, all right. Okay, so now, first thing is remind you that there's a exam a week from today. So the exam will be next Thursday. Okay, and this is the final list of review problems. Okay, so I added a few more. I dropped a few problems and added a few problems in the last day or two. So that's the final list. Okay. Does anybody have any questions about the exam? Yeah. Anybody got any questions that have come up since Tuesday? Anybody want to ask anything at all about the exam so far? Anything about the review problems or anything about the exam?
Is the exam handwritten or can we type on the computer?
Oh, you can do it either way. You might need to, probably handwritten is better because I'm going to probably ask you to draw some of these memory diagrams where you draw boxes, showing variables and what they hold. So for example, in here, there's a couple questions that ask you to draw a memory diagram for like how the Java visualizer would draw it for that little bit of code. What are the let's see. Here's the problem. Okay. Draw a memory diagram like we did. We find one. Yeah, diagram like that. I'll ask you to draw a picture real similar to that, where you say what the variables are, what the turtle objects are, and which variables point to which turtles. You don't have to draw what's inside the turtles, but you have to show the variables, the objects, and which like here the main thing that was important here was that and that Yertle and Y3 were names for the same turtle. Okay, yeah, there's 1, 2, 3, 4 turtle variables and only 2 turtle objects. Or I'm sorry, there's 3 turtle variables and 2 turtle objects. And then there's 1 world variable and 1 world object. Okay, so problems like that, you need to be able to draw a picture. Okay, so I think you should think of it as an exam where, as I said the other day, you'll be given these problems on as a PDF document. You could print it out, write the answers on it, or write your answers on blank sheets of paper. You'll write your answers on blank sheets of paper or write them on the exam, then scan it using one of these, using a scanning app on your phone, or this is one you could use, Adobe Scan. Okay, use some app to scan your document in and submit it back to me as a PDF document. Okay, so yeah, you'll probably want to write the answer. Now, some of the problems are short. You write short explanations. Some of the problems where you just have to like write in what word would go into that blank there. Another kind of problem is you have to complete a couple lines of code. Like what's a couple lines? A couple lines of code would go in here. So you have to write 3 or 4 lines of code in there. You have to finish that line of code there or finish that line of code there. So writing it would be a good way. But a lot of these you could type them, but if you want, you could also just write them, on a piece of paper. The easiest thing would be if you could print out the exam and write your answer on the exam. That would be the easiest way to take the exam, if you have a printer. If you don't have a printer, you'll have to write your answers on a blank sheet of paper and then scan them in. Okay, so but the exam is essentially a paper and pencil exam. It's basically a paper and pencil exam where you're answering questions like these. Okay, we don't have an automated testing system where we could create an online test like this. That not many people have things like that. They're hard to build. So the exam will be pretty much writing the answers. What about other questions? Any other questions about the exam?
How long do we have like to take the exam? Because
Well,
can we
I'll
start
make it
after
available
tonight?
after class, so that'll be at 5, and I thought it'll be due at midnight. So you have the evening to do it. Okay, so it's an
Said
exam
this
where
Thursday.
Wait,
night,
when
or-
does the exam open?
after class, I'll make the exam available, and it'll be due at midnight.
I mean, like what day is what I'm saying.
The day is week from today.
Okay.
Okay, so today is the 24th. It's October 1st. Okay, yeah, everything's, a lot of, it's yeah, the first midterm exam is 1 week today on Thursday, October 1st. First midterm exam is a week from today. So make sure you check all the information that's up here. Check the information that's up that's here. Okay, and for example, make sure you look here and see what sections. Here I tell you exactly at the top which sections that we've read are on the exam. You're responsible for those sections, chapters 1 through 5 of the Think Java book, and these sections from the other book. Okay, and there are links to all those on this page. If you start from the beginning, there's links to every one of the reading assignments. There's chapter 1. There's a link to sections 1.3 and 1.4. Okay, so okay. Now, what about other questions for the exam? Okay.
So
I don't have one on the exam, but I was gonna ask, where do we submit the homework at? 'Cause I
Oh,
can't find it.
yeah, that came up the other day and I forgot again. Yeah, somebody sent me an email to remind me. I have to create the tool to create it. I keep forgetting to go to Brightspace and make the tool for adding for the homework assignment. Yeah, somebody sent me an email to remind me because I've forgotten twice now to
Okay.
create that tool. Yeah, there isn't one there. You're right. It's missing from it's missing from the Brightspace site. I've forgotten to create the tool you use to submit the homework assignment. Okay, so yeah, somebody send me an email and then I'll remember. I can do it right after class. It only takes me about 5 minutes to create the tool. Okay, yeah. So thanks. Like things like that. Remind me. Send me an email. Yeah, if you notice something's missing, like like the tool for submitting, just send me an email. There there's so much stuff that I have to keep up with. Believe me, there's a lot and it's easy to forget something. It's easy to forget. Mostly, the material's up on this website, so I don't go to Brightspace all that often. You could probably go to Brightspace much more often than I do. I prefer a public website for this material than a private Brightspace. Brightspace is closed. Nobody only people who are registered students can see the Brightspace. Not even other computer science students can see the Brightspace. This CS 123 course can only be seen by people who are in CS 123 in Brightspace. I don't really like that. I think anybody should be able to see this. So I like having it as a public website. So I don't actually go to the Brightspace page all that often. That's why it's easy for me to forget to create that tool, because I don't go to Brightspace all that often. So if please send me reminders. If you see something missing, please let me know. Okay. Well, other question. Anybody got other questions about what about the homework assignment? The current homework assignment, that's due on Tuesday. Okay, so the homework assignment's due on the 28th, on Tuesday. Does anybody have a question about the homework assignment? Now you've been working on it for a while. Anybody have a question about it? If you have questions about the homework, please send them. Send an email, ask about it. It's a tricky little assignment. It's not trivial. So you have to be reading the material in the. You have to download the zip file. Look at what's in the zip file. Okay. Oh, and remind you that what you need to really do you need to read this thing here. You know, you'll need to figure out yourself which of these methods could be useful for you. So you need to read this page, yeah, and read what each of these methods do and ask yourself, could you use replace or not? Would you need to use to upper or not? Is length of use to you or not? Would trim be useful to you or not? See, these are the things that you can do on strings. And so, you know, you need to read the assignment carefully and also go to this page here, read the list. It's like a menu. It's a menu of items that you can choose on a string. Would to lower be of any use to you? Probably not in this assignment, but to upper will be, because you have to capitalize something. So to upper could be useful to you. Okay, so go, yeah, make sure you read the stuff here.
Professor, for the homework, do we
Mhm.
need to worry about if the user entered nothing or a space?
No,
Oh.
it even says that here, right?
Oh.
See, assume that there are no spaces before the first word. So you don't have to worry about them typing space, space, space. This is a sentence. Yeah, you know, the first word will begin right at the beginning of the string. Okay, so you don't have to worry about there being blanks at the beginning or if they enter all blanks. Your program doesn't have to deal with that. It can assume that there's a first word right at the beginning. Okay, yeah. So yeah, that would make it a harder problem. If you allowed them to type possibly blanks at the beginning, it'd make the problem a little bit trickier, or it'd make it different. So okay, so you don't have to worry about funny things like spaces in front of the sentence. Okay, so what about other questions?
This goes back, and I might have missed it because I was late to class. But for the exam next week, will we be in like a Zoom meeting?
No, no,
Okay.
no. Yeah, I'll make it available at the end of class, and then you'll have till the whole evening to work on it. So from like from 5 to midnight.
Okay, thank you.
Yeah. So yeah, you have the evening to do it. Okay. 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 Other questions about review problems, exam, or homework assignment? Anything else? Okay. Let me see. Let me close some stuff I have left over. Okay. Now, what we want to do is talk about more about if statements. Okay. Oh, let me remind you again, these review problems, work on them. If you have questions about them, ask. You know, as I point out, I think I was pointing out last week, I'm not going to give you an answer sheet to it. I won't give you an answer sheet to these review problems, but I will answer any of your questions about it. I'll tell you if you got a question right or wrong. If you have it wrong, I'll tell you, I'll give you a hint about how to fix it. So the goal is, this is the way you learn, is by practicing on on problems. So going through these problems is a really good way to make sure you understand the material. So it's a very good, the process of solving these is where you do the learning. So I'm not going to produce a solution sheet, but I will answer any questions you have about it. Okay, and you can talk to other people in the class. If you have a friend, anybody in the class, and you work together on it, that's fine. Not on the exam. You're not supposed to work together on an exam. Exam's supposed to be done individually. Yeah, but if you have questions about these problems, or if you want to work with somebody on these problems, that's fine. Okay, so yeah, if you have questions about them, please ask. All right, so what we want to do now is start talking. This section 3.4 is the next thing to do. That's the next. We've talked about if and if else statements. We've done a lot with, and we did these examples. We did a bunch of examples of if else statements. We've done lots of examples of if else statements the other day. We want to now talk about something called an else if statement. And this is a little bit tricky. Okay, this is where if statements become hard. So far, if statements aren't really hard. it's not hard to understand an if statement, but it comes a little bit tricky when you start introducing the else if. All right, so let me show you an example problem. Now, what I want to do is, let me put this in Dr. Java, and then we're going to do an example in Dr. Java, and then we'll move it up to the Java visualizer to see a little bit more about it. Okay, so here's a little problem. It's a real simple thing. We're going to, oh, you see that spinning circle? Sometimes, I don't know if it does it on your machine, but Dr. Java, when it starts up, sometimes just starts up blocked. See, it won't do anything. It won't let me and if I close it and I start it, this happens about every other time I start Dr. Java. If I do it again, it won't do it. See, now this time it'll be okay. I'm not sure why that's happening. It didn't used to do that. I don't know if it's Windows 10, if it's a Windows 10 issue. See, now there's no little spinning circle. Yeah, see, now everything's fine. I can click on menus. But every once in a while, my Dr. Java starts up and it's just blocked. I get the little spinning circle, and I just have to close Dr. Java and start it up again. And I've never seen it do that before. It started doing it this semester, and I don't know if it's something. Dr. Java is a little bit old of a program. It might have issues with Windows 10. Anyway, okay, so now I got Dr. Java running. Here's the problem. I'm going to create a scanner, prompt the user to enter an integer between 1 and 5. I'm going to read their integer into a variable, and then I'm just going to do a simple thing. If they entered 1, I print out you entered 1. If they entered 2, I print out you entered 2. So this is a way for me to ask what they printed. If you entered 3, you printed out 3. If 4, print out 4. If n is 5, print out 5. Okay. And then this thing is here is, what if they entered 17? Well, this says if n is not 1, and it's not 2, and it's not 3, and it's not 4, and it's not 5, I didn't get one of the numbers I wanted, so I give a little error message. Okay, so compile and run this. It's real simple. It's not interesting, but it's meant to show us an idea. So if I enter 2, okay, and I hit enter, you enter 2. Run it again. I enter 4, and I hit enter, and you entered 4. And then just show you one more case. If I enter something like 15, if I enter 15, it says we asked for a number between 1 and 5. That came from this last one here. Okay, now let's move this up to the Java visualizer, and let's watch it run, because it's a little bit interesting to see what it does when we watch it run. So I'm going to move it up to the Java visualizer. The advantage of the Java visualizer, it lets me watch it run. Instead of it just running, I get to watch it run. Okay, so I'm going to visualize it. Oh, I have to go back here. The Java visualizer can't take keyboard input. Since I want keyboard input, the Java visualizer, like the other textbook, you need to give the input ahead of time. So I'll put the number 3 in here. That's my input. That's the equivalent of Dr. Java popping up this little box. But instead of that box being popped up while the program is running, in Dr. Java, in the visualizer, you have that box pop. You have to fill in that box before you run the program. The Java visualizer can't deal with your keyboard, so it makes you type the input ahead of time. So visualize this. Okay, there's my input. My input will be 3. So the scanner will read from this box. The scanner will get its data from there. So I create a scanner object. I print the message to the user. I print my message to the user. Now this is kind of the fake part. The input isn't going to come from the user. The input's going to come from this number over here. Okay, so now that number got copied into n. Now let's watch what the if statements do. Okay, if n is 1, well, n is 3, it's not 1, so I skip over that. N is 3, it's not 2, so I skip over that. Okay, if n is 3, well, it is 3, so now I'm going to skip into that one, 22, and I'm going to output the message. Okay. Now here's the kind of interesting part. We asked the user to type a number between 1 and 5. We now know that they typed 3. We don't need to check if it's 4. We shouldn't have to check if it's 4, because if it's 3, it can't be 4. And if it's 3, it can't be 5. But notice that we still check n equals 4. Then we check is n equal 5. Then we check, is it the case that the user entered a number not between 1 and 4? Notice how we kind of did checks that we didn't really need to. Okay. If we know the user entered 3, why are we still asking, well, is it 4? Is it 5? Because they can only enter one number. And if we know it's 3, it can't be 4. This is something called mutually exclusive cases. A number can't be 1 and 2 at the same time. If a number's 1, it can't be 2. If it's 2, it can't be 4. These are mutually exclusive cases. If you have one of these true, all the other have to be false. Now, that's not always the case when you have if statements. You could have a situation where this if statement could be true or false, this one could be true or false. But in this case, if one of these is true, all the others have to be false. If any one of these is true, all the others have to be false. That's called mutually exclusive. We want a better way to write code for this. We don't really want to do this kind of thing. We don't want this to be saying, check if it's 1, check if it's 2, check if it's 3, check if it's 4, check if it's 5, check if it's none of the above. If once we know what number it is, we shouldn't have to check for any other numbers. So for example, if I go back here and I do the case of 1, once I know that the number is 1, I really should be done at this point. You know, I know the number is 1. It cannot be 2, 3, 4, 5. But I still have to check, well, is it 2? Is it 3? Is it 4? Is it 5? Is it none of the above? Then I'm finally done. Okay. So what's a better way to do this? The better way to do this is what the textbook refers to and what people refer to as these else-if statements. Okay, so that's a way to make this kind of problem written better. Okay, all right, now let's look at another point of view. Okay, now we're going to talk about the same idea of an else-if statement, but from a different point of view. Okay, so let me open up another file. Yep, open it in Dr. Java. Okay. Here's another, this is going to be another point of view, and then we'll see that the 2 points of view are really the same thing. But I'm going to start talking about what seems to be something else, but I'm really still talking about the problem of mutually exclusive cases. Okay, so what we're dealing with over here is the problem of coding mutually exclusive cases. If one of our cases is true, we know all the other cases are false. So why are we checking every one of them when we know that only one of them can be true? Okay, so now here's another point of view. If somebody gives you an if-else statement, you can put anything you want inside there. You can put anything inside of an if-else statement. So you could put another if-else statement inside of an if-else statement. That's called nested if-else statements. Okay, you have one inside of the other. Okay, now notice here I put an if-else statement inside the if part of an if-else statement. See, it's in the if part. The other possibility is I could put an if statement in the else part, or I could put one in both. Okay, I could put one in both. I could put one in the if part and one in the else part. But it turns out these are logically kind of different. Okay, putting an if statement in the if part of an if statement isn't actually very common. This doesn't solve very many problems. It's not very common, so it doesn't even have a name. It comes up sometimes, but not often enough to have a name for it. Okay, so this is putting an if statement inside of the if clause of an if statement. So if nested inside if. What's way more interesting is an if statement inside the else part. This has got a name. It's so important it's got a name. It's called else if. So you can kind of see what we've got here is else if. Okay, so that's why the book referred to this idea of there's a section on else if statements. Okay, so there's this whole section on else if statements. Okay, and you can see now here how they wrote it else if. We haven't written it that way yet. We're leading up to that, but they wrote an else if there. Okay, so let's go back. So here's what we're doing. Start with an if statement. And since you can put anything you want inside of an if statement, you can put an if statement inside of an if statement. But there's two places to put it. So you can put the if statement inside of the if clause, or you can put the if statement inside of the else clause. This one's not that interesting. It doesn't have a name. We don't call it if. You don't call it an if statement or anything like that. It just doesn't really solve too many ish problems. It's useful, but not as useful as this next one's going to be. The other thing what's really interesting is to put an if statement inside of the else clause. Then you get what people refer to as else if, and it solves the mutual exclusion problem. Remember we started with what we're interested in is this mutual exclusion problem. We have a bunch of cases where if one of them is true, the others must be false. You can't have two of them true. They're mutually exclusive. If this one's true, it excludes all the others from being true. The right way to write this code would be to use these else if clauses. We'll see why, but these are the thing to solve that problem. You nest an if statement inside of an else clause. Okay, now you can keep on doing that. This else clause here can have anything I want in it. I can embed another if statement in that else clause. So notice I've got multiple nesting here. I've got an if statement up here. It's got an else clause. The else clause has an if statement in it. That if statement has its own else clause. Then that else clause has got another if statement embedded in it. Okay, the ifs are all inside the elses. So here there's an else if. Here there's an else if. Okay. All right. Now this is so common that we abbreviate it. We abbreviate it to look like this. What I'm really doing here is the following. Let me start from down here. Notice that there's only one statement inside this else. And if you remember, we told you that a rule in Java is that if you only have one line of code, this is really one line of code. It starts here at the I and ends here at the brace. This is officially one line of code because it's one if-else statement. If you have only one line of code in an else clause, you don't need the braces. So Java has a rule, and we did that in the examples we did last, where is it? In the example code we did, notice I started out, there was only one statement in there. It was a print statement, but I didn't put a brace here because there's only one thing between if and else, one line of code. So I didn't put braces. There's only one line of code after the else, so I didn't put braces. That's not really a good idea, but I didn't put the braces because I'm not really required to, okay? So over here, people really cheat. They say, if you got an else clause with an if in it, and that's the only thing in it, get rid of that brace because there's only one thing in there, and get rid of its companion because there's only that thing in there. All right. Now, cheat a little bit more and back this guy up so he's on the same line as the else. Now I have an else if. I actually haven't changed any meaning. I just have now an else if. And now I can back this up to be indented with the else. Okay, and I kind of gotten rid of one level of indentation. I actually haven't changed the code. I'm just reformatting it. But now I do the same trick again. This else has only one thing in it. This is all one big statement. It's really one long single line of code. Since the else has a single line of code in it, I don't need those braces. So I'm going to delete that brace. I'm going to delete that brace. But now Java doesn't care about spacing, so I'm going to go ahead and cheat and just put that up there. And then I can back up this indentation to there. I'll back up this indentation. And now I have what we call an else if statement. See, now I have this thing it's just a way of rewriting all the nested if statements. Okay, so if I Control Z my way out of this, go back to where it was. Okay. Okay. Here is an if statement with an else clause holding an if statement with an else clause holding an if statement. So I've got 1, 2, 3 levels of indentation. But using the tricks I just showed you, that brace doesn't really need to be there. That brace doesn't really need to be there. Without the brace, I can back this if up to be over here. That brace doesn't need to be there. I can back this if up over here. I get this. Now let's read it. Here's what it says. If something, well, actually, let's read it from here. It's a little bit easier to see for you. If this guy's true, you do what's in here. And then if this guy's true, you're done with the if statement, you skip over the else clause. Now notice that makes this guy mutually exclusive from everything inside here. Why? If he's true, you do what's in here and you skip the else. That's why all if statements work. If this is true, you skip the else. But if this is true, you're skipping all these other conditions. So if this is true, you know that these don't even get looked at, which is actually what we want. Remember, what we really wanted over here was, if we know that this is true, why are we checking all these others? See, if we know that's true, why did we do all these? So we don't want to do all those, but that's exactly what we have now. If by nesting them like this, if this is true, I'm not going to look at any others. Now suppose this one's false. If this one's false, I go to the else clause. The first thing in the else clause, I check this. If this is true, I do this and I skip the next thing. See, if this one's true, it now is exclusive of the things that come after it, the things that are nested in its else clause. Because if this is true, I skip the else and anything that's nested in it. So now I'm in a situation where if the second one is true, I don't want to do all these other ones. Okay, so I want it to be, if the first one's true, I skip everything after it. If the second one is true, if the first one's false, but the second one is true, I want to skip everything after it. If the second one is false, but the third one is true, I want to skip everything after it. And that's what I get over here. Whichever is the first one, if I look at it from this point of view, whichever the first one is true, that's what I do. If this one's true, do this. If this is false, go to the else. If this is true, do this and skip everything else, because you're skipping the else of that if statement. So if this one's true, do this, skip everything else. If this one's false, I go and check this one. If this one's true, I do this, skip everything else. If all of these are false, I do this one, which notice it doesn't have an if statement. It's the default case. This is the one that says none of the above. Okay, so this one handles none of the above. This one wasn't true, this one wasn't true, this one wasn't true. So I have a default case of what to do in that case. That was in our other example, this one down here, where the number is not 1, not 2, not 3, not 4, not 5. But here I had to spell it all out. Not 1, not 2, not 3, not 4, not 5. I don't want to have to spell that all out. See, down here, I know that see, this will be if n is 1, if n is 2, if n is 3, and this will be none of the above. Okay, so now let's go over here and rewrite this one. And it's really easy to rewrite it. What we do is we put an else here. That's all we need to do, put an else there. And now we change the logic from, if this is true, do this. If this is false, then, well, check this guy. Else, check this one. If this is true, do this. If it's false, I need an else here. And now I need an else here. Notice how it's really easy to modify this to be the right way. Even though it took a lot of explaining, it's a simple change. Now this reads, if n is 1, print out this, and you're done. If n is not 1, else. If n is 2, print this, and you're done. If n is not true, well, other. That's why sometimes I told you, sometimes some languages call this otherwise. It actually reads better otherwise. If n is 1, do this. Otherwise, if n is 2, do this. Otherwise, it actually reads nicer if this word was otherwise. But Java didn't choose to use the word otherwise. They choose to use the word else. Some languages do use it there because it reads real nicely. If n is 1, do this. Otherwise, if n is 2, do that. Otherwise, if n is 3, do that. Otherwise, if n is 4, do that. Otherwise, if n is 5, do that. Okay, Java, else. If n is this, do this. Else, if n is that, do that. Else, if n is this, do this. Okay, once one of them is true, you skip the rest. Okay, now this program behaves. Oh, no, I haven't finished yet. Down here, I don't need any of this logic here. What I replace all that logic with is just the word else. And it's better, again, it reads better if you think otherwise. If none of these are true, otherwise do this catch-all case, the default case. But Java doesn't use the word otherwise, it uses the word else. Okay, so now, if that's not true, 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 I catch anything. Now this would be the case of a number that's not 1, 2, 3, 4, or 5. Notice I don't need any more crazy logic here. I can just say it wasn't one of these cases, so it must be the default case, not a number between one. It's not 1, 2, 3, 4, or 5. When I run this program, it actually, let's see, no. Oh, I'm sorry. I can't, this is not real Java code. This is a quirk of Dr. Java. See, I have 2 files open. And you might run into this problem. I want to compile this one. But when you click the compile button in Dr. Java, it compiles both your files. Okay. Actually, I wish it didn't do that. It compiles both the files. This is not a legitimate Java file. This is just an explanation. So this does not compile. So what I need to do is close it. I need to close this file because I cannot compile this one while I've got this one open with problems in it, which means you can't work on 2 files at the same time in Java, one that's good and one that's got problems. You can't compile the good one while the other one's got problems. And that's actually a real mistake in Dr. Java's case. They should only compile the window that's open. When you click the compile button, they should only compile this window. But there's a reason why they did it this way. And in some uses of Dr. Java, it's very convenient that if you have 5 files open and you click compile, all 5 of them are compiled at once. That's helpful in some cases, but it's a problem in other cases. My preference is if you had 5 files here and you wanted to compile them, you would click on this one, compile it, then click on that one, then compile it, then click on the other one and compile it. Now that's a nuisance, but that case comes up less often than you just have 2 files. One is correct and one is incorrect, and you can't compile the correct one because the incorrect one's stopping you from compiling the correct one. Okay, so Dr. Java has this weird quirk. So I have to close that one, and I probably should close the untitled one also. Now I can compile this one. Okay, now this runs exactly like the one that didn't have the else's in it. So when I run it, I don't see any difference. So if I run it and I type in 3, I get output, you entered 3. If I run it and enter 0, we ask for an integer between 1 and 5. But now if I build this one up into the Java visualizer, now we'll see some big differences. So when we watch it run, this is why the Java visualizer is so helpful and so important. When we watch this run, we see that it's really different than the previous version. So here's the previous version in the visualizer. I want to keep that one. Open another tab to the visualizer. Put the new version in there. here's the improved version of this guy. Okay, all right, so this is the one that checked everything every time. Here's the improved one. Okay, now let's watch it run. Now we got to give a number for input. I'll give the input 2. Okay, let it run. Okay, grab the 2. Okay, now I got the 2 in a variable in the program. It got read from standard input into the program. So the 2 is in the program. This is not part of the program. This is what remember, this represents what the user types in. So it's not the program. It needs to be, this data needs to be scanned into by using the scanner. We need to read in that integer. Okay, now I can check my code. Okay, is n equal to 1? No. Skip over. Is n equal 2? Yes. So print this. Now, the beauty is, where do I go next? I'm not going to check this because I just did the if part of an if statement. So the definition of if statements is when the if part is true, you skip this else. But this else holds all that code. So I'm skipping all of it. So I'm going to go from line 18 to line 35. Well, actually 36. See, I skipped all the other code. I did not needlessly check, well, is N3, is N4, is N5? See, it worked the way we want. The program really says what it means now. The number is either 1 or it's 1, 2, 3, 4, or 5. Once you figure out which one it is, you can stop checking for any of the other numbers. Okay, let's try another one. Let's go ahead and enter 15, which is not 1, 2, 3, 4, or 5. What's going to happen now? Well, I do have to check if the number is 1, 2, 3, 4, or 5. So I do need to ask, is it 1? No. Is it 2? No. Is it 3? No. Is it 4? No. Is it 5? No. Well, if it's not 5, it wasn't 1, 2, 3, 4, 5. Unless I jump from 28 into the catch-all part. See, I jumped from 28. I checked if n equal 5. That was the last thing to check for. It wasn't 5. So that means it wasn't any one of the things I was looking for. So I'm in the otherwise, the default clause. It's the case where we asked you to enter a number between 1 and 5. Okay. So the way we think of this is we use else if statements. Now, it's really not an else if statement. It's an if statement at the beginning, a bunch of else if clause. It actually should be called an else if clause. There's an if clause at the beginning, a bunch of else if clauses, and an else clause at the end. We think of these as mutually exclusive cases, and this is a default case to catch anything that wasn't in one of these. These are mutually exclusive, meaning that we want this to mean that if one of them is true, all the others must be false. So only one of them can be true. And then we have this guy down here to say, well, if none of these were true, this is what to do otherwise, the default case. Okay. People call this an else if statement, but that's actually not it's really not only an, see, it starts with if, then it's got a number of else ifs and has an else at the end. Some people kind of you'll occasionally people refer to these things as if else statements, because that's what it really is. It's an if else statement. Okay, because you have an if at the beginning, then you have as many else ifs as you want, and then an else at the end. But nobody's going to call them if else statements either. Occasionally you'll see a textbook called that way. People usually just call them else if statements. Okay, and remember, what it really means is that we're nesting an if statement inside of the else clause of an if statement. Okay, so if we go back to our this diagram, the starting point was if you have an if statement, an if else statement, you can put anything you want in there, you can put anything you want in there. Well, What if you put an if statement in there, in the if part? That's okay. That's occasionally useful, but it's not a pattern that has a name. Putting an if statement inside of the if part isn't a pattern that we give a name to, that we use all the time. But if you put the if statement in the else part of an if statement, that's the pattern that's really useful. That's the pattern that gets called else if. Okay. And if you can keep on doing that. You can, like, I can put another, see here I've got one if statement inside of another. I've got 3 nested if statements, 1, 2, 3, nested inside else parts. If I wanted, I could put another one in here. I can say if something else, I have more things to check. And then I would say, okay, there's what to do if more things is true, else do something else. Okay, oops. I can keep doing this. I can keep putting, I mean, this, now I have 1, 2, 3, 4 mutually exclusive cases. Remember over here we had 5, and this really wasn't very unreadable. You'll find code with 20 of these. You'll find programs where there's a chain of else ifs that are 20 long. Chains of 5, 6, 10 are not that unusual. 20 is maybe not that common, but there's nothing, it's easy to write. If this, else if that, else if that, else if that, then your logic here, what to do in that case, what to do in that case, what to do in that case. So if this is 1, 2, 3, 4, 5 if statements nested together. Okay. Whereas over here, I've now got, notice it's this, if you write it this way, it becomes real unreadable. This is 1, 2, 3, 4, and then here's the 5th one. It starts, you wouldn't want to indent this. This is one of the extreme places where you really don't want to show the proper indenting. You want to cheat and use this cheating indenting with where you just get rid of these, get rid of the superfluous braces, like this one here, get rid of the superfluous braces. That one's matched up to that one. Get rid of those. Why can I get rid of them? Because the only thing in the else clause is that one thing. There's only one thing in that else, so that brace is superfluous. So this is one of the few cases where you don't want to properly indent, because that's way harder to read than what this would be. Here I would add, like this has got now 1, 2, 3, 4, 5. Down here, to add the 2 more, I just do else if even more. Was that what I called it? No, more things. This one would be more things. Check more things. Else if even more. See, it's really easy to add clauses. Okay, now I've got 5. Now I've got the 5 levels of indentation that this one really has. But I really don't want to write it that way. No one ever writes it that way. No one writes their else if statements in their glorified indented form. Everybody uses this abbreviated form because it's real easy to add clauses, remove clauses. Like if I, for some reason I can reorder these clauses if I wanted to. What's interesting is if I go over here to this problem here, it doesn't matter what order I check those numbers in. This is still a correct program. Absolutely, totally correct. And it would be hard to complain about it other than that, you might just say it's dumb to write it this way. But it turns out that a lot of times when you have these mutually exclusive cases, there's not an obvious ordering to them. If this case is exclusive from this one and this one and this one, sometimes there's a logical ordering to them, but sometimes there isn't. So it doesn't really matter what order you put them in. Notice that this will check. If n is 1, do that, skip all the others. If n is 5, do that, skip all the others. If n is 3, yeah, it's harder to tell if I have the number. I have 1, 2, 3, 4, 5. Notice it becomes harder to debug it if I order it funny like this, but it's correct. Okay. No, so notice that by writing it this way, it's real easy to move things around. If I were to try to move this indented one somewhere else, it'd be a nightmare to move it around because you have to re-indent everything. It would just be, notice it would be really hard to move these clauses around, even though logically they're exactly these clauses here. And these are easy to move around. You know, I just showed you, it took a couple seconds to move around these clauses. So this is a really great way to write code. These else if clauses are real, they're easy to write, and they're real useful. Mutually exclusive cases come up a lot in programming. You know, you roll a die and you get a 1, a 2, a 3, or 4, or 5, or a 6. You don't get 2.5. You don't get anything else. You know, there's just a lot of cases where you just have, you know, you're going to read in some data, but the data has to be one of many cases. You know, the data is not just completely random. It's going to be, you know, the data is either going to fall into this bin, this bin, this bin, or this bin. So mutually exclusive cases are a real common pattern. So we give it a name. You know, we give it this else if name. Okay. All right. Now, here's a. Now let me switch this number test one to be a little bit different. Okay. Right now, I asked for someone to just give me a number from 1 to 5, and it's an integer number. So the number is either 1, or it's 2, or it's 3, or it's 4, or it's 5. Okay. Let's change it to not be integers. Let's change it to be doubles. So I'm going to do this in the Java visualizer. I'm going to take this version in the Java visualizer. And instead of asking for an int between 1 and 5, I'm going to ask for a decimal number between 1 and 5. And we'll see that that makes things a little bit different. So open up another Java visualizer. I'm going to ask the user to enter a decimal number between, and I'll ask it to see between 0 and 5. Okay. And then I'll ask for next double. And this is a double. Okay. All right. But now it doesn't make sense to ask, is it 1? Or is it 2? Or is it 3? What I want to know is, I want to know, did they enter a number between 0 and 1? So you entered and I'm going to change these to between 0 and 1, between 1 and 2, between 2 and 3, between 3 and 4, between 4 and 5, and then we ask for a number. We asked for a number between 1 and between 0 and 5. Okay, so this was between 0 and 1, between 1 and 2, between 2 and 3, between 3 and 4, and then between 4 and 5. All right, now what, but see, now I have to change this. Okay, so now I have to say, well, I want the number between 0 and 1. So I want n to be greater than or equal to 0. And this is the way I say and in Java. I want it to be, I want n to be greater than 0, and I want n to be less than 1. Okay, that's between 0 and 1. Then over here, I'm going to do a little copy and pasting because it's going to be really repetitious. Here it's going to be between what? I want n to be larger than what? So n should be larger than what now?
1.
1, yeah, see, I changed it to n is larger than 1 and less than 2, okay? And then over here, I want it to be larger than 3, larger than 2 and less than 3. And then here I want it to be, if I'm going to say the numbers between 3 and 4, the number has to be bigger than 3, and it has to be less than 4. And then this is between 4 and 5. Okay. Now let's see if this works. Okay. Now, what I want to show you is that I can write this in a little bit better way. I mean, right now, actually, I haven't written it the way a Java programmer would want it written. We'll see in a minute what I can do better than this. Okay, but let's see if this works. So let's see. Let's put in, say, 3.2. Visualize execution. Okay. Read in our double. So there's our number. We want it to show up in our program. So now it shows up in our program. N is 3.2. Okay. Is 3.2 greater than 0? Yes, that's true. And 3.2 less than 1? No, that's false. This one's true, but this one's false. So I don't have the and. I don't have, and means I want both of them, just like in English. I want both of them to be true. So if this one's true, this one's false, so I don't have the and, so I skip over. Is 3.2 larger than 1? Yeah, it's larger than 1. That's true. Is 3.2 less than 2? No, that's false. So I have this one, but not this one. I have this true and this false, so I don't have them both true. So I don't have and this, so I skip over. Is 3.2 larger than 2? Yes. Is 3.2 less than 3? No, it's not. 3.2 is, this one's true still, but this one's still false. Okay, so I don't have both of them. Okay, now is 3.2 larger than 3? Yes. Is 3.2 less than 4? Yes. Okay, so this is true. Now, notice that this one's going to be false anyway. This one will be false also, because you won't have this one true. But I won't check it. Remember, these are mutually exclusive cases. Once I fall into this bin, I'm done, because every one of these bins is mutually exclusive. 3.2 is not greater than 4, so this is going to be false. So I mean, but I won't bother to check it because I know it's going to be false because I wrote these in a mutually exclusive way. So I'm going to say now the output's going to be enter a decimal number. You entered a number between 3 and 4. Okay, right? Because I entered 3.2. All right, so it's working the way we want. Okay, now watch. I can write this in kind of a clever way. Okay. It's still right. This is a hard problem. Why is the program still correct? Very subtle, and programmers do this all the time. They abbreviate their code. Why is it okay to ask if n is less than 2 here? Because what if somebody types in 0.1? 0.1 is less than 2, but 0.1 is not between 1 and 2. Anybody want to try? Think of it. What's making
Is it
this?
because the code would stop at the first one?
If
or at
what?
the if statement?
Yeah. You would never get to here if somebody entered 0.2. Why not?
It would stop after if.
Yeah, it would. The 0.2 would make this true, which would be between 0 and 1, and you're skipping all this. You don't get to this one if the number's between 0 and 1. Since by entering here, I know I'm not between 0 and 1. I don't need to check again. Remember what it was, it said, if n is greater than 1. Well, I know n is greater than 1 because it wasn't, this one was false. I wasn't between 0 and 1. Since this one's false, I have to be here, okay? Now, there is a little bit of a problem. This won't work if I allow negative numbers, okay? If somebody enters -5, I do have a problem here. This won't quite work if I let somebody type in negative numbers, because -1 would be less than 2. -1 wouldn't be between here and here, and -1 would be here. So this trick actually only works if I require the user to enter a positive number. Enter a, okay. So I'm actually, to make my program, to make this trick work, I do have to make sure that they enter a positive number, okay? And if they enter a negative number, my program will give them a wrong answer. And this is not, I warned them, enter a positive number. If they enter a negative number, my program will not, we'll see, it won't do the right thing if they enter a negative number, because a negative number would make this thing true, okay? In fact, then I actually don't even need to do this one. Because if they enter a positive number, it's greater than 0, and then I just want to know, is it less than 1? Then I want to know, is it less than 2? It won't, since I've already checked that it's less than 1, all I need to check here is it less than 2, because I know it's not less than 1 because I skipped over this. Then over here, I can drop that, and here I can drop that, and here I can drop that. Now again, this only works if I make sure that I'm counting on the person only entering positive numbers. Okay, now let's try it. The input's 3.2. I deleted too many things there. I deleted one of the parentheses. Okay, get my number. Okay, is 3.2 less than 1? No. Is 3.2 less than 2? No. Is 3.2 less than 3? No. Is 3.2 less than 4? Yes. Print out my answer and skip everything else. Okay, so it did the right thing. Okay, now let me just show you that if I enter a negative number, all bets are off. My code really is written under the assumption that people really do enter a negative number right now. The way it was written before was safer in that sense. Okay. The input's -1. Okay. Notice that that's not right. I'm gonna output now. You entered a number between 0 and 1, but the user entered -1. They did not enter a number between 0 and 1. I asked for a positive number. My code was assuming they gave me a positive number, and if they gave me a negative number, my code did the wrong thing. Sometimes that's okay in programming. If your code makes the assumption that it's getting that kind of input, then your program, sometimes it's allowed for your program to say, my program only works when I get the kind of input I expect. Sometimes it's not allowed to do that. It's actually kind of a tricky issue. Right now, this program is correct if I assume that the user gives me the right kind of input. But my program is wrong if the user gives me the wrong kind of input. That, in some situations, that may be okay. In some situations, that's not okay, and I better check. I better check. So for example, here's what I could do. I could put an if statement at the beginning. I could just say, if n is less than 0, if n is less than 0, please enter a positive number. Okay. Then turn this into an else. So now I start my mutually exclusive cases. Now my program is fine. Okay. See, now I've added another case. if the numbers to the left is 0 on the number line, which is one whole case exclusive from all these others, then it's a negative number and I give them an error message, okay? And then else if n is less than 1. See, now by the time I get here, I know the number is not negative. And so since it's not negative, it's going to be not negative from then on, because all these are nested inside of this guy. And he checked that the number is not negative. I only get to this else if the number is not negative. Okay. So now my program is structured fine. And now I've written it in a real easy to read way. I don't need those extra. I don't need the thing here that says that if n is between 0 and 1, if n is between 1 and 2. Notice even though I say here it's between 1 and 2, I don't need to check that, because this thing already checked that it wasn't between it. What this thing told me that I'm not less than 1. So by the time I get here, I'm not less than 1. If I am less than 2, then I'm between 1 and 2. Weird logic. Now, some programmers would write this the verbose way. Not many would. The verbose way would be to say if there's the like, but that's this thing is redundant with that. Okay. Some people say, oh, but if you write it here, it's easier to read this. If n is greater than 0 and less than 1, you enter the number between 0 and 1. If n is greater than or equal to 1 and n is less than 2, you enter a number between 1 and 2. But this is redundant. Okay? This is redundant. This is redundant. And one philosophy is redundant code is some code that can be, it's just code you have to worry about that's not doing you any good anyway. So why would you write code that you have to worry about if it doesn't need to be there? So a lot of programmers would not put it there. See, here I didn't. So I just need, by the time I get to this else if, I know that's false, and that's false. So I know that my number's larger than 2 by now. See, I've checked for all the cases that are less than 2. So by here, I know I'm larger than 2. So it makes no sense to really say if n is greater than or equal to 2, that's redundant. Okay? It's redundant to ask that question at this point. So you don't have to. Okay? Okay. Now, this is where programming starts using subtle logic. We're actually starting to think using logic. You know, we have to read all these things together. We're using the word and. We want this to be true and this to be true. Even though here the and was actually superfluous, it's redundant because it's, you know, we only get here if that was false. But if that was false, n is a positive number. So I don't need to ask that again. See, I only get here if this is false. If this is false, n is positive. So why do I bother to ask it again? Okay. I only get here if all this is false. If this is false, n is larger than 1. So I don't need to ask it again. So it's superfluous here. Okay. All right. So mutually exclusive cases sometimes introduce kind of subtle reasoning. You know, this looks like you're checking only that n is less than 3. So you might, if you didn't read this carefully, you'd think that this conflicted with that. See, you would say if n is less than 3, you enter the number between 2 and 3. And then someone's going to say, but that's stupid. That doesn't make sense. If n is less than 3, why are you between 2 and 3? And you have to read that. You can't read it like that. You have to read it like that. You only get to this guy if you did all of these up here. Very subtle. You only get to this statement here if you've gone through all these others. So this condition here is built on top of all those other conditions. That's part of this game of nested if-else statements with mutually exclusive clauses. So you get code that's sometimes hard to read. You can't say, what does this clause do? You can't say, you can't answer it by just looking at it. You can't tell me what this thing does just by looking at it, because what it does is dependent on what this one did, what this one did, and what this one did. You know, this logic here is not really standing by itself. It's based on what happened here, 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 and then you get to this one. So these nested else if clauses can lead to tricky code. So it's a common, it's something common, but it's also something that can cause confusion. Okay, all right, let's see. Okay, oh, notice that this was easier because the answers were just 1, 2, 3, 4, 5. Okay, so this was a real simple example of mutually exclusive things. This one makes it just a little bit more tricky, more realistic, because because I switched from integers to doubles, and now the numbers are between 0 and 1. Now I have something a little bit more. Oh, I can't change the order of these. Oh, remember over here I said you could reorder these all you wanted? Not anymore. Okay, on this one, if you took one of these clauses and moved it around, then it doesn't work anymore. Okay, it would work if you kept this part here. Okay, if you kept the verbose part here, then you can move the clauses around. But for example, if you reverse that clause and that clause, the program will be broken. If you reverse this clause and this clause, it'd be okay. Now, you might say that's an advantage of leaving this verbose stuff in there, but usually you don't want to be reversing the order of these clauses. But if you leave the verbose stuff in there, then you can move these clauses around. If you take the verbose stuff, if you take the redundant stuff out, then the clauses have to be in that order. The order matters. In this one, the order, because it's so simple, the order didn't matter. Okay, that's more subtlety. You know, that's more subtle stuff going on in programming. Here, order didn't matter because the tests were so simple. This test really didn't rely on what was tested before it. But when I write it this way, especially if I get rid of if I get rid of these redundant clauses like here, here, and here, I can't reorder it anymore. The order now matters. I better check for 2 before I check for 3. And I better check for 3 before I check for 4. And you have to go home and think about that. Well, you are at home, but you have to, after class, you have to think about, go through these examples and convince yourself that what I'm saying really makes sense to you. That if you reordered that, and even do it, try it. Reorder that clause and that clause, reverse their order. The program will be okay. It'll run correctly. Reverse that clause and that clause's order, and you'll see the program gives you wrong answers. Those two clauses can't be reordered. They're mutually exclusive, but the logic here depends on the logic here. So even though they're mutually exclusive, this one does depend on that one being there before it. These ones are mutually exclusive, but they're also isolated from each other. Because this guy checks everything, he checks that n is greater than 1 and less than 2. That makes them independent of the one that came before it. So you can reverse the order. Most programmers would not write it this way. They would not write it that way. They would write it that way. Just because that code is redundant, so why should it be there? By being redundant, it lets you reorder it, but reordering is not important. What's more important is you don't want redundant, unneeded code. You don't want to write unneeded code. That's more important. Though, if there was a reason to want to reorder these, you might want to write it that way. You never say never. You never say that you have to write things a certain way. Here it's just, okay, if I throw this in, it's redundant code. I might think it makes it easier to read. It makes it a little bit easier to read. It would let me do a goofy thing like reorder these clauses, but that's not what people think is important. What's more important is not have unneeded code. Okay. Any question about this example? This is a subtle example. Even though we're just playing with numbers, it's already pretty subtle logic. Anybody got any question? We're going to use this stuff for the rest of the semester. we will make lots of use of nested if-else statements, okay? Or what people call else-if statements. We'll make lots of use of these nested else-if statements. So we'll see lots of subtle cases where, you know, where especially this trick of this code depends on this code coming before it. Well, this code depends on this code coming before it. So you have to know what happened here before you can ask what's happening here, as opposed to this one where this one didn't care about what happened here because I wrote it, I put the redundant code in it. We'll see lots of examples like this, okay? Now let's see. One last thing, remind you, remember, what started it all was in an if statement, you can put an if statement here or an if statement here. Putting if statements there, not that interesting. Putting if statements here opens up, if you want, a can of worms, or if you want, it's a really good tool. Putting the if statement here doesn't mean it's useful, but not all that often. But putting the if statement here, that's really different, really powerful. It leads to the else if idea. So that's one way to think about it. The other way to think about it is mutually exclusive. I've got things that if one of them is true, I know the others are not. So if I'm doing some logic where I've got 5 things to check for, but I know that if one of them is true, the other 4 must be false, I use else ifs. So that's another way to think about it. Mutually exclusive things, okay? If any one of these is true, the others must be false, okay? So if you're thinking of something that's mutually exclusive, you think else ifs, okay? All right, we've run out of time. If you have a question about the homework, if you have a question about the review problems or about the exam, you know, or about what we're talking about, please send me emails. Anybody have any last question? Anybody have a question at the end here? I'll put these examples up. Yeah, these are subtle examples. Go back and reread them. You know, go back and think about, you know, what's changed from here, which was just using integers, to here, which was using well, this, yeah, how did we improve things from here to here? And what made it harder when we went from integers to decimals? Okay. Why was this not as good as this? And why is this harder than this? Okay. That's what you think. What made this not so good? What made this better? What made this harder? Okay. All right. Any question? Okay. So we'll meet again on Tuesday. Please send me emails or, you know, come to office hours, ask her for a Zoom meeting, you know, if you have any kind of questions at all at any time. And I'll go ahead and stop sharing and have a nice weekend. See you again on Tuesday. Bye.